Hi, hello everyone. So this time around, I'm going to show you how to use second order Lagrange interpolating polynomials. So this is the examples that we have. So we have 3 points in here. Oh, sorry. So this is the points that we have: x1, x equal to 1, x equal to 4, x equal to 6, together with its the value of the function at the respective x point. All right. So this time around, we're going to find out what is the value of the fx. We want to estimate the value of the function. Okay. We want to estimate the value of the function when when x equal to 3. Then this time around, we are going to use second order Lagrange. Yep. So if this is second order Lagrange, means our n is equal to 2. Okay, let's start. Right. So because this is second order Lagrange, so we will be having f2 x equal to, remember that we have this summation from I equal to 0 until n. So this time around, our n is 2. And then we have Li f xi. Then we need to expand this because our I is equal to 0, 1, 2. So we're going to have 3 terms in here. So it's going to be L0x fx0 plus L1x fx1 plus L2x fx2. Alright, so this time around, we need to find out the function for Lagrange L0, L1, and L2. Now coming back, we want to find out the value of the function when x equal to 3. Okay, so x equal to 3 is somewhere in here. Alright, and also you need to know that we need 3 points in here because our I takes the value of 0, 1, 2, meaning that we need to have 3 points. So we are going to use all the points in here, starting with, because this is the only point that we have, and the point should include this value. So it's going to be our x0, so we'll choose our x0 as this one, this is x1, and this is x2. Therefore, this is our fx0, fx1, fx2. Okay, so let's start with the Lagrange, finding Lagrange when I equal to 0. Okay, so when I equal to 0, we'll have L0x equal to, so we have this as j equal to 0 until j equal to 2, and this j cannot be equal to the I, so our I currently is 0. Okay, and we have this general formula of the Lagrange, x minus xj divided by xi minus xj. Okay, we are going to expand this, but before we expand this, I would like to explain you again on this one. So this one is, you know that our j will take the value from 0, 1, and 2, but we have this added condition here, which is it cannot be equal to 0. So we only have j equal to 1 and j equal to 2 for this part. So it's going to be x minus, so this time around our j is equal to 1, so x1, this is x1, and our I is 0, so that's going to be 0. And remember that we need to multiply this. Okay, so we'll have, because this is multiply, so we have x, sorry, So this time around, our j is 2. So x equal to, x minus x2. And this one is xi. Our I is 0. So x naught minus j is 2. So x2. Okay. So we can plug in the value. So we plug in the value of x1 and x2. So we know that our x1 is 4. So that will give you x minus 4. So this one, our x naught is 1. And this one is 4. Our x2 is 6. Yeah. Sorry, 6. So x naught is 1 minus x2 is 6. Okay, so that will give us, okay, I'm going to erase this a little bit. Oh, sorry. So we will obtain x minus 4, x minus 6 divided by, this is minus 3, this is minus 5, so that will give us x minus 4, x minus 6, so this is 15. Okay, done with L0, Lagrange 0. Now we will continue with I equal to 1. So we're trying to find L1x. Okay, again we have this symbol here where this is multiplication. So we'll start with j equal to 0 until j equal to 2. And remember that j cannot be equal to I. So our I now is 1. Yeah. And we have this general equation for Lagrange, x minus x j divided by xi minus xj. So that will give us, okay, again I'm gonna explain to you what is this all about. So we know that our j will take the value from 0, 1 until 2. But j cannot be equal to 1. So we're going to cross this. We're not going to have this. So it's only j equal to 0 and j equal to 2 that we're going to evaluate. So it's going to be x minus, so when j equal to 0, so this is x0. Okay, then this one is x, our I is 1. Okay. J is 0. Okay, remember that we have to multiply with the next j value. So x minus our next j is 2. So x2. So this one is x1 because our I is equal to 1 minus x2. Okay. I need to check this one whether I'm doing it right. Okay, correct. So here is x minus x naught. Our x naught is 1. Our x naught is 1. Okay. Our x2 is 6. X2 is 6. And then x1 here is 4. X naught is, okay, this one is just following 0. This one just follow. So this one is 4 minus 6. Okay, so this will give us x minus 1, x minus 6 divided by 3 multiply by minus 2. So that will give us x minus 1, x minus 6, and minus 6 here. So this is L1. So we need to do this again. Similar approach for I equal to 2. Okay, now let's find L2x. L2x, we have this multiplication from j equal to 0 until j equal to 2. But this time around, our j cannot be equal to I, so our I now takes the value of 2. Okay, so again, we will have this general equation for the Lagrange. So this is xi minus xj. Okay, now we will, okay, again, what is this all about is we have our j equal, our j takes the value from 0, 1, and 2. And this time around, our j cannot be equal to 2. So we're going to cross this. We're not going to find this value. So we only have j equal to 0 and 1 only. So then, it means that we have x minus, so the first j is 0, so x 0. So our I is 2, x2 minus x naught. The next j is 1, so it's going to be x minus x1. Okay, and then this one is, sorry. This one is x2. Oh my god, I'm so sorry about this. x2 minus x1. Okay, so then we will have x minus x naught. Our x naught is 1. So basically, this one will follow. x2 is 6. x2 again, x2 is 6. Okay, x2 is 6. 6 minus 1. Then we have x minus x1. x1 is 4. Sorry, x1 is 4. Okay, so this one, x2 is 6 minus 4. Okay, so we will have x minus 1, x minus 4 divided by 5 times 2. So that will give us x minus 1, x minus 4 divided by 10. So we are done by determining all the Lagrange values. So now we need to plug in into this formula. Okay, so when we want to plug in this formula, okay, I'm gonna use another color here. We want to plug in this formula. Okay, remember that we're trying to find L2x. Oh, sorry, not L2x, sorry. We are trying to find F2x, second order Lagrange. So we have L naught x. So this is the one. So we need to copy this one. So it's going to be, it's going to be x minus 4, x minus 6 divided by 15. And remember that you need to multiply with this, fx naught. So fx naught is 0. So this is 0. Okay. Plus L1x. L1x is this one. So it's going to be x minus 1, x minus 6 divided by minus 6 multiplied by fx1. So our fx1 here is this one. So that will give you 1.386294. Okay, then next is plus, remember the next one is L2x, so our L2x is this one, so that will give you x minus 1, x minus 4, divide by 10, yeah, multiply by fx2, so our fx2 is this one, so that will give you 1.791759. Okay, so basically this is the equation for second order Lagrange for this particular example. Now remember that you need to evaluate x equal to 3. Yep, so you need to plug into this. So you're gonna have f2, our x now is 3, equal to, so we need to substitute all the x with 3. So 3 minus 4, substitute all this with 3. This one also, yeah, this one also. Okay, so 3 minus 6, 15, 0, plus 3 minus 1, 3 minus 6, minus 6, multiplied by 1.386294, plus x is 3, so 3 minus 1, 3 minus 4, 10, 1.791759. Okay, so you need to solve all this. You should solve all this and you will get the estimation value. That's it.